The universe is ancient. It's unimaginably vast, and by all accounts, it should be absolutely buzzing with life. So, why is it so quiet? That simple question is at the heart of one of the biggest, most profound mysteries in all of science, the Fermi Paradox.
So picture this. It's 1950. The brilliant physicist Enrico Fermi is just having lunch with some colleagues. And thinking about the sheer age and scale of the universe, he just casually asks this simple question that stopped everyone in their tracks. If the galaxy is full of life, they should have gotten here by now. So, where is everybody?
And to really get why that question is so powerful, you have to appreciate the scale we're talking about. Our home galaxy, the Milky Way, has somewhere around 300 billion stars. And we now know there are way more planets than stars. Trillions of them could be in the Goldilocks zone, where water could be liquid. The number of chances for life to get started is just staggering.
And that is the paradox right there. On one hand, the numbers scream that the universe should be a cosmic metropolis, full of civilizations. But on the other hand, when we actually look out there, we see nothing. We hear nothing. Just a vast, eerie silence. This giant gap between what should be and what we see is the Fermi Paradox.
So how do we even start to get a handle on this? Well, an astronomer named Frank Drake came up with a famous tool called the Drake equation. Now, it's not a magic calculator that spits out the right answer. Think of it more like a framework, a way to organize our ignorance by breaking that one giant question, are we alone, into a bunch of smaller, slightly more manageable pieces.
So let's quickly walk through it. It's basically a string of probabilities multiplied together. You start with the rate of new stars, multiply that by how many have planets, then how many of those planets are habitable. The first few variables, we're actually getting pretty good data on those now, thanks to new telescopes. But then, we hit a wall, a big one. What fraction of those planets actually get life? And how often does that life become intelligent? And how many of those build something we can detect? And then, the biggest mystery of all, how long do they stick around before they disappear? The last few parts of this equation are total, complete guesswork.
All that uncertainty leads us to this incredibly powerful and kind of chilling concept called the Great Filter. The idea is that on the long, hard road from simple chemistry to a galaxy-spanning civilization, there is at least one step that is almost impossibly difficult to overcome. A wall, a barrier that almost nobody gets past.
So, where is this Great Filter? Well, one of the main possibilities is that it's behind us. This is the first major solution to the paradox. The idea that for all practical purposes, we are alone. Why? Because we somehow won the cosmic lottery and passed the hardest test already.
Now, this idea really comes in two main flavors. First, you've got the rare Earth hypothesis. This says that the filter was getting the perfect combination of ingredients. The universe has lots of planets, but almost none of everything needed for complex life. The other idea is that maybe the conditions are common, but one of the biological steps, like life appearing from non-life in the first place, or the jump from a simple cell to a complex one, was a complete statistical fluke, a 1 in a trillion shot that we just happened to win.
And I mean, just look at the checklist of things Earth has going for it. You need to be in a calm, safe part of the galaxy. You need a stable star. You need a huge planet like Jupiter to act as a cosmic bodyguard, deflecting asteroids. You need a magnetic field, plate tectonics, a large moon to stabilize your axis. The list just goes on and on. Maybe getting a planet is easy, but getting a planet that checks every single one of these boxes is next to impossible.
Okay, but what if the Great Filter isn't behind us? What if we're not special at all? What if the galaxy is actually teeming with intelligent life, but they're just hiding? This leads us to a whole second category of solutions, the ones that assume the aliens are out there, we just can't see them for some very compelling reasons.
One of the most popular ideas here is the zoo hypothesis. Basically, it suggests there's a club of very advanced civilizations out there, and they've all agreed to a kind of prime directive. They've designated Earth as a cosmic nature preserve. They're watching us, maybe studying us, but they're intentionally not interfering to let us develop naturally. We're in a zoo, and we don't even know it.
Then you have a much, much darker explanation, the dark forest theory. This one is genuinely terrifying. The idea is that the universe is like a dark forest, full of hidden hunters. You can never know the intentions of another civilization, and since they could be a threat, the only logical survival strategy is to stay dead silent. And if you happen to spot someone else making noise, you eliminate them before they can eliminate you. In this view, the silence we hear isn't an empty galaxy, it's a galaxy holding its breath in fear.
Or here's a more sci-fi idea. Maybe it's not about fear. Maybe it's about boredom. Perhaps really advanced civilizations inevitably turn inward. They master their own consciousness and just upload themselves into massive simulated universes that are way more interesting than our clunky physical one. I mean, why would you bother colonizing cold, empty space when you can create infinite, perfect worlds inside a supercomputer?
But all of these hiding scenarios have one massive problem. And this quote from futurist Isaac Arthur really nails it. These theories require every single alien civilization for billions of years to all follow the exact same rule of staying hidden. It only takes one group of rebels, or one curious explorer, or just one tourist to break the silence and give the game away. The odds that absolutely everyone would stay quiet forever, they seem pretty low.
The fact that hiding seems so unlikely leads us to a third, and maybe the most powerful possibility. What if we're all tied in knots for no reason? What if the Fermi Paradox isn't a real paradox at all? What if it's just an illusion, created by our own bad assumptions? There's this fantastic paper called Dissolving the Fermi Paradox, and it argues we've been using the Drake equation completely wrong. We've been plugging in single best guesses for each variable, but for things like the odds of life starting, we don't have a best guess. Our uncertainty is massive. So, instead of plugging in one number, the authors plugged in ranges of probabilities for each variable, reflecting how much we truly don't know. And when you do that, everything changes.
The results are pretty mind-blowing. When you properly account for all the uncertainty, their model finds there's a 52% chance that we are the only intelligent civilization in the entire Milky Way. And, get this, a 38% chance we're alone in the entire observable universe. Suddenly, the silence isn't a paradox that needs some exotic explanation. It might just be the most statistically likely outcome. The paradox just dissolves.
So what do we do with all this? Where does it leave us?
Well, whether we're completely alone or just the first ones to the party, the implications for how we search for life and what it means for our own future are absolutely massive.
The first thing to remember is our search has barely even begun. For a long time, SETI was just about listening for radio signals, but now we're getting way more creative. We're searching for technosignatures, things like the waste heat from a Dyson sphere, which is a hypothetical megastructure that a super advanced civilization might build around its star. We're even using AI to pore through mountains of data looking for anomalies that a human would just never spot.
And that brings us to the most sobering thought in this entire discussion. Okay, let's say life is common, and let's say they're not hiding, and let's say the paradox is real. What could the silence mean then? It could mean the great filter isn't behind us, it's in front of us. It would mean that civilizations get to about our level of technology all the time, but something terrible always stops them from going any further.
And what could that filter be? Well, the list of candidates is basically a list of our own worst fears: an artificial superintelligence we can't control, an engineered pandemic that's unstoppable, climate change that spirals into a hothouse Earth, or the classic global nuclear war. The paradox, in this light, becomes a cosmic warning. It suggests that developing the power to transform or destroy your own planet is the final exam, and so far, looking at the silent sky, nobody has passed.
So in the end, we're left with this one haunting question. When we look up into that great silent darkness, are we looking at a pristine wilderness, an empty frontier waiting for us as the firstborn of the galaxy to explore it? Or are we staring into a cosmic graveyard, filled with the ghosts of countless civilizations that reach for the stars but ultimately failed? The answer defines everything about our place in the cosmos and the stakes for our own survival.